Today we're looking at vectors, which are something which did a while back under transformations, at least the first part of it, but there is going to be some new stuff I'm going to have to do. So just to start you off, copy this down. If you've got your exercise books, make sure you use the squares, and we're looking for column vectors which look a little bit like coordinates, only they're vertically written, to say how something moves rather than exactly where something is. So pause the video and give it a go. Right, to work out what moves A to B, the top number is your horizontal shift. So I'm going to put an X down for that. This isn't the answer to the first one, by the way. This is just a bit to tell us about the rules. And the bottom number is going to be your vertical shift. So just as when you were in primary school with coordinates, you were told to go along the corridor and then up the stairs, the same sort of idea here. The only other thing is to think about your coordinate grids and the fact that you have a little arrow going up for Y and to the right for X. That's going to be key here. To go from A to B, I'm just going to put a dot on one of the three corners of my shape and then count how far I have to go right. 1, 2, 3, 4, 5. Because that's 5 right, that means I'm going to have a 5 at the top, because as you're going to the right, it's getting bigger and therefore more positive. And then it's going down 1 to there. Now that I've worked that out for the one part of the shape, it'll be just as true for all the other points. So I only have to count it for 1. So that's 5 along, and then it's down 1. And because it's down 1 and not up, up is positive, that's going to be my -1 there. So if that's what moves A to B, what's going to move B back to A? Well, it's going to be the same thing, so or the same thing in reverse. We're going 5 to the left, and to the left is -5, and we're going 1 up, so that is +1. Right, so if that was all news to you, you might want to pause it before doing C to D, or if you've already done it, just let it roll on. So I'm going to pick a point. I'm going to make it this one. This time looks easy. From here, 1, 2, 3, 4, 5, 6. So that means it's going to be 6 for my right shift, and then up 2. So that'll be +2 there. The vector that moves D back to C would be 6 left, which is -6, and 2 down, which is -2. Okay, so far that's all stuff that we'd learnt before. Now we're going to start combining them and seeing what happens when you add vectors. Here's our next problem. So write it down on a grid. Draw the vector m equals -3, 5. Pause the video. Have a go at whatever you think that might mean. Right, so we're going for -3, 5. So -3 would be 3 to the left, and +5 would be 1, 2, 3, 4, 5 up there. Now that's not drawing it. What's drawing it would be this part here. So if I do this in purple, what we actually want is your M looking like that. So just to reiterate, we're going from there, we're going up to the point that is 1, 2, 3 to the left, and 1, 2, 3, 4, 5 up, and then it's a straight line, so I should use a ruler really, and that is my vector. Right, so can we think about this the other way, looking at a vector and then describing it just from a picture and describing it using the column vector. So pause the video, have a go, and then see if you agree with me. So A is going to the right 4, so to the right 4 is like that, it's not going up or down, so that's 0. B is going to the left 1, to the left 1 is -1, it's also going down 1, and that's -1 as well. C is going straight down. Now straight down is 1, 2, 3, 4, 5, -5. It's not going anywhere laterally, so it's a 0 for your x value. The fourth one, D, that's going due left, so left is -1, 2, 3, 4, 5 squares, and it's not going up or down, so that's a 0 for your y shift. E is going 1, 2, 3, 4 to the left and 2 down, so that's -4 and -2. In the F we're going 2 across, so that is to the right, so that's +2, and we're going up 1, 2, 3, 4, so that's also positive and 4 this time. G, the purple vector, goes 1 to the left, so that's -1, and it goes down 1, 2, 3, 4, 5, 6, so that's -6 as well. And H is 2 to the left, which is -2, but it's 2 up, which is +2. Right, so that's that. We're going to move on next to a little bit of adding and taking vectors. Now imagine I had a very simple snooker table that had pockets in the 4 corners, which we're going to call A, B, C and D. I hit the snooker ball at 45-degree angle, so it's going exactly through the corners of these until it hits the side of the table there. Now because the table's a perfectly made table, the ball is going to bounce away at the same angle as it went in. So it went in at 45, it's going to come out at 45. And it's going to bounce there. It's going to continue on doing the same idea. Now before it goes any further, I'm going to say, right, we're going to have, that is our first column vector, and hopefully you agree that that would be 3, 3 as a column vector. And the second part of the journey is going 2 to the right, but it's going down 2, so I could call that -2. The third part of the journey is going 1 left and another 1 down. So we've got back to the bottom. If you look at that, 3 take 2 is 1, take 1 is 0, so it's got back to there. But we are still 1, 2, 3, 4 across to the right. 3 plus 2 is 5, take 1 is 4. Now if I were to continue on with this, I would get up to there, wouldn't I? So what have I done there? I've gone 3 to the left and 3 up. And then I go 1 more to the left, which is -1, and I go down 1 again. Then I go down and to the right 2. So that is 2 positive, and down 2 is -2, and then it goes 3 and it goes into the pocket, so that's a relief, isn't it? We don't have to go any further, so that would be adding another 3, 3. If I were to add all of these up, I'm going to get 3 plus 2 is 5, take 1 is 4, take 3 is 1, take 1 is 0, add 2 is 2, add 3 is 5 for my x shift. And then my y shift, I'm going to have 3, take those, gets me back to 0, then up to 3, then down to 0, then back up to 3. So altogether my vector is 5, 3. And if I were to take a different colour now, like the purple, say, and draw a straight line from A to C and ask you just to do that one single vector, that would give us 1, 2, 3, 4, 5 to the right and up 3. So what that's actually doing by doing this is simplifying our whole journey. Our real journey was doing that, but in effect I've gone 5 to the right and up 3. So hopefully that shows you a little bit of the point of adding vectors and taking them as well. So here's where we step it up a little bit more. So if vector p equals 2 minus negative 3, write the following as column vectors. Pause the video, have a go at what you think might happen. If you like, try drawing it out. So when I said try drawing it out, what I meant was p is 2 to the right and then down 3, so that is p. So 2p would just be do that twice. And if we've done that twice, we're going to be doubling both the movements. So it's going to be 2 times 2 and 2 times negative 3, which is going to give us 4 negative 6. A half p could also, by the way, folks, be written as p over 2. That would be the same thing. Is going to be the same idea, but it's just going to be half of it, isn't it? So you're going to be halving, so it'll be 2 divided by 2 and negative 3 divided by 2, and that's going to give us 1 over negative 1.5, or negative 1.5. And the last one, negative p, well, if p is doing that, negative p will be doing exactly the opposite. So negative p would be just multiplying them both or dividing them both by negative 1. So you'll have negative 2 and positive 3. It's how you'd get back like we did at the very beginning. Last bit for today, write this down and give it a go. If q equals negative 1 for your x shift and 3 for your y shift, find and draw the following vectors. Pause it and have a go. Right, so it says find and draw. Let's start by just drawing q on its own, shall we? So we're going left 1. In fact, I'm going to go over here because I'm going to do it a few times then, aren't I? I'm going left 1 and left 1 and up 3. So so for A, left 1 and up 1, 2, 3, that would be q, that would be 2q, that would be 3q. So what is that? That's going to be, what am I talking about? Why have I gone, I've gone negative 2 each time, haven't I? So let's redraw that. We're going, sorry about that, negative 1 and 3, isn't it? Negative 1 to the left and 3 up, 1 to the left and 3 up. So that's going to look like that for our 3q. And all together we've done 3 times that, making negative 3, 3 to the left, and we've gone up 9 squares. Now if we do that for 5q, that's going to be the same idea but going even further. So that's 3, that's 1, negative 1, 3, once, twice, 3 times, 4 times, 5 times, and if you count all of those up, you should get -5, and 5 3s are 15. 1.5q, well, it's going to be half of that one, isn't it? Or just half again of what we had. So we're going, instead of 1, we'd be going 1.5 to the left, and then we'd be going up. Half again of 3 is 4.5. 1, 2, 3, 4.5. So that's going to look something like that. It's parallel to this. It's just exactly half of what we drew there, isn't it? So that is -1.5 over 4.5. And -2 will be doubling everything. So if I start here, go 1 to the left, up 3, do it one more time, 1 to the left, up 3, and there's my -2. Oh, -2q. I've done that wrong, haven't I? So when I times -1 times 2 and 3 times -2, when you times by a negative, of course, that's going to change it to +2 and -6, because we're going in the other direction. All I've got to do is change the arrow on there, because it's 2 to the left and 6 down. Well, I hope that made some sort of sense. Please let me know if you found that really confusing, or before letting me know, try watching the video a second time and see how you get on. All right, cheerio.